So before we start today, everybody, so I'm Jenny, the community manager here at Iterative, and I'd love to have people from the community introduce themselves today. Dave is here, he's from the team, Julie's here from the team, but feel free to unmute your microphones and say hello and introduce yourself. Daniel?
Hi, I'm Daniel Barnes. I missed the first part of that. My audio was still connecting, so I missed that.
All right, nice to meet you. Daniel has been a really great contributor on the CML side. So you might see his name a lot in Discord in the CML channel. And
Yes.
Here comes Casper. Alejandro, you want to say hi?
Hi, I'm Alejandro. I am in London, and I am a machine learning lead at a startup in London called Bohurst. And I just started using DVC. I've been sort of watching it for a while, but I haven't really sunk my feet in it. So I'm just here to learn.
Okay.
Hi, everyone.
Good place to be. Ah, there's Justin. How are you today, Justin?
Great. It's Thursday.
Thursday, yes. Thursday,
Yeah.
office hours day. Cool. Okay, anyone else want to introduce themselves? Alex, I haven't seen your name before. Alex Ellard.
Yeah, hi. I'm joining from the UK, from Exeter in Devon. If people know what that is, it's kind of out of the way. But yeah, joining, I'm working as a machine learning engineer for a startup in Exeter. We're starting to use tools like DVC and CML. So just here to, learn like everyone else, I guess.
Cool, awesome. Great to have you here. What about Rob C? Today we have Ivan Chan. He's a mechanical and back-end software engineer and graphic designer at Continuum Industries. And his colleague, Andreas Malekos, who wrote the blog post that inspired this presentation today, he's going to be presenting that. So I will let him get started, and I'll put the link to the blog post in the chat, and he will give more about himself and tell you about the cool ways he's using our tools.
All right. Hi, everyone. Welcome to my talk. It's about in Continuum Industry, our company, how we use ML tool stack. And yeah, in today's the basic agenda, I'm going to go over a little bit about myself, about my company, and what is the objective, what is our goal of using the tool stack that we have, how we're using it, and what it is itself, and our pipeline, our algorithm testing pipeline, and why we use CML and how we use it, as well as DVC as well, and hopefully give you some real life test case use cases on what was how we're going to use it. So so a little bit about me. Like, my name is Ivan Chan. I'm an AI engineer in Continuum Industry. I work with the algorithm, and we call it optimization engine, and I am in charge of developing it, as well as the continuous integration, continuous deployment, and continuous testing of our algorithm pipeline. And yeah, so that's part of my job. I also work on other stuff, but that is one of my responsibilities in the team. So our company, Continuum Industry, is a startup company that is in the infrastructure sector. We automate and optimize the design of the linear infrastructure assets, for example, pipeline, power line, power cable, weld, and roads. So anything from any other infrastructure that is from A to B. So our product allows something that's previously border civil engineering for months to design the assets. It would we shorten the time for design from a month time, or even 3 months time, down to about a couple of days or even hours. So our main product, Optioneer, it takes input data, for example, geospatial data, or design rule set, whatever we define the objective would be, the unit cost for building certain things, And then all of those information, those input data will be plugged in to our optimization engine, our algorithm. And that would output different route that can be exported into CAD or different analysis along with that, and it's ready to use. And this process can be iterated over and over again until something is good for the project, for a particular client, for the or the infrastructure owner, the assets owner themselves. So this is one of the example of one of the onshore cable project that we did with one of our clients. And as you can see, so that would be something that is produced with different code, different route, and so on and so on. It's based on the geospatial data, and then the input that is given by the client, the length, the cost, etc., etc. Oh, so let's jump into the ML tool stack. So we have a very robust ML tool stack, MLOps tool stack. But from that, what we want to achieve with that is we want to make sure our algorithm can always produce good and correct solution to the end user. By we mean the route that you just saw in the previous slides. When civil engineers look at it, they would have to agree on that, and they have to say saying that, oh, it is really good, it looks good, it would be something that we can produce and out into clients. It has to be correct as possible. So all the engineering quantity, the objective, the cost, the CO2 emission, it has to be calculated as accurate as possible. So those are things that we need to make sure the quality of it. So in that case, we need to develop a very robust QA process for our testing. So we have to continuously monitor our algorithm performance of it and weekly testing the algorithm themselves. In order to achieve that, we have been using a lot of tools. So we are our algorithm primarily written in Python. So this is along with the C packages that you can see there. And we use Git for our code versioning, version control management. We use DVC for our data versioning and control and management. And we use Neptune for experimental tracking. And we are using GitHub Action along with CML for our pipeline for the algorithm testing, which we will go over in the later slides, as well as Kubernetes and Argo workflow for the algorithm, how to run the algorithm themselves. We're using AWS, so EC2 instances or other services to make the process a lot more seamless, and all the other things for unit testing and computation. So this is one of the pipeline for testing. This is for our algorithm specifically, and is a GitHub action. And it will get triggered automatically once a week, or it will get triggered for every pull request, and they run different level optimization. For the one that's once a week, it will run a full optimization from beginning to end. And then for the pull request one, it will run a dummy one to check if there's anything is broken or not. So initially, we will be spawning instances on Amazon with the EC2 instances, and those are the runner that we use to run all of our test cases. So in parallel. So depending on number of test cases, we're responding different number of instances. And what is each test cases? It consists of two things. So one is the geospatial data, and then the other is the configuration setting for our algorithm or the problem. So that is managed by Git, and the geospatial data is managed by and versioned by DVC. And then multiple of cases are running at the same time in parallel. During the running of it, Neptune will be tracking all of the metrics Neptune AI will be tracking all of the metrics and parameters that we use in we have in each run, and then at the end of it, there will be a post-processing script to take all of the metrics that generated and store in Neptune and processing as different output, so we can quantify it, the performance of our algorithm, and then a unique ID which can send back to the developer, including myself, and then we would be looking at it and then iterate it over and over again. Yeah, so this is okay. How do I go to the next slide? Yeah. Oh, okay. So I don't know how to remove that one. Anyway, so I want to draw your attention into this stage, this particular stage of our pipeline. So we are using CML. We're deploying a runner with CML. So this EC2 instance is deployed with CML for running the test cases. Why do we want to do it? Because by using CM, so because before using CM, it was very difficult and time consuming to know exactly how our algorithm perform. It can perform good or it can perform badly, but we just don't know because there are so many cases that we're running in parallel. And we don't know how it's going to perform in one cases when compared to the other. So it takes me usually about 1, 2, or 3 hours to go through all the cases to make sure everything is working just fine. And then I move on. But that was too time consuming. So that's where CML comes in. It helps us to automate that process because it provides a very simple and easy way to let the team know if there's a bug or if there's any algorithm issue that we unforeseen, and then let the developer know without any additional services required. The way it does it is it generates a very clean, elegant summary or table, or even a graph at each pull request. So we know how the algorithm performed before we merge it. So if there's anything wrong with it, we can instantly pick it up right at PR before merging. Now I want to draw attention into the top pack of our algorithm pipeline. So for each test cases, we are using DVC to do our geospatial data versioning and management, and we're using Git to do it. So each test cases, it consists of basically 2 packs of it, a configuration file and a relatively large geospatial data file. So what is the problem is each geospatial data file define our optimization problem. For example, let's say if there's a geospatial data that is produced like a year ago that is kind of outdated, what the root previously is impossible might become possible in the new geospatial data. Or someone that built a house in a previously feasible area, and then the geospatial data get updated, it's no longer possible to build infrastructure through the house anymore. So those kind of things changes all the time, and those kind of update is quite regular, and the optimization problem will change. However, in order to ensure the algorithm is performing correctly all the time, we need the problem to stay the same between runs, so it can provide some meaningful comparison and meaningful metrics. If the problem changes all the time, like the metrics doesn't actually make sense, doesn't actually tell you much about it. This is why we need. That's why DMC provide a really good solution to it. It's because it provides a very easy way to version and manage those large file and data set, specifically the geospatial data set. And it has a built-in integration of Git and S3 bucket. So it was very easy to use, because I remember before we were using DVC, we had a custom solution with S3 bucket, and we have a custom module specifically built to manage it. And it turns out to be very difficult to do. And it was too big a project for a team, for 4 people to manage. And DVC just allow us to do it without additional services. And it also allowed us to have a specific version call. So let's say right now the geospatial get updated. When we updated the geospatial data on DVC, we can run the previous version to check if the previous version, the output of the previous version still remain valid and correct. So that really help us to do continuous testing to ensure our algorithm performing as well as possible. And so, yeah, so this is our tool stack, and this is our algorithm. And honestly, I think DVC and CML really did help us on the whole automate the whole algorithm stuff, because previously there was a lot of issue with it, and the Neptune AI provide a lot of good tools for us to do experimental tracking, but there's inherent limitation into it. And DVC allow us to do data versioning and management and fit into the gap where Neptune AI doesn't provide us. And I hope this unique use case can inspire some of you to use DVC and CML in your day-to-day work stream. All right, thank you very much. If you have any questions, feel free to ask me.
Do we have any questions? That was really great, Ivan. Thank you. I love being able to see like it all visualized like that.
Yeah, sorry, the circle thing, I could manage to delete it. Oh,
there it goes. Hey, we've got some claps from Julie. Does anyone have any questions for Ivan? One question I have is, so like you said, these things that you had to do before DVC and CML took so much time. Like how much time savings did you get by adding these things into your workflow? Would you estimate?
Yeah, so I would say, because we are running the algorithm pipeline weekly, and on Monday, I have to go on each individual cases. We have 66 test cases. So we have to go to individual cases and do comparison weekly. And that took me about 2-3 hours a week. And then now it just took me like 2 or 3 minutes just read the report on GitHub. So, wow. which is really helpful. Mm-hmm. Yeah. And for DVC stuff, previously we have to manually just go on whenever things get updated, we get a notification and we have to go and update it bit by bit using our custom function. And that doesn't happen too regularly. That'll happen about once a quarter, but that would take us about a day or two. And now it's just like we just have a custom script with DVC and then just run it and it's ready. We don't have to have any time into it. Mm-hmm.
Good to hear.
Yeah, it's great to hear that people like using our tools, and it's made your life a lot simpler. I mean, especially the setting up and starting cloud runners, AWS instances, and that sort of thing. You actually have the entire CML team who developed this online right now on this call. So I guess one question would be, did you have any troubles with it? Are there bugs or issues that you'd like to, see improved?
Yeah, actually, we had some issue. I think my colleague actually posted an issue, and your team was very quickly to respond to our message and then provide a workaround. Yeah, with it. Yeah, I remember it's something to do with the ID. People sometimes just change it for no apparent reason. Yeah, so that was a really good workaround, and then everything got fixed within hours. So good job to your team.
Cool.
Yeah. We don't have any trouble like, at the moment, but if we have, we would be submitting issues. And yeah.
Cool.
I have a question. I apologize if it's stupid. I'm new to all of this. You mentioned that you're using the stack to sort of run in parallel a series of experiments. There is nothing in DVC though that like is sort of orchestrates this parallelization.
No.
I was just wondering.
We orchestrated using GitHub Action, using the matrix itself. But DVC allow us to, the CMLs allow us to, DVC and CML allow us to run things in parallel in a way that just help us to do that. Because we have different, DVC allow us to save multiple of geospatial data, and our GitHub workflow just take those geospatial data at request. And because those geospatial data are versioned and stored using DVC on S3 bucket, so we can just take them all down whenever we want it, whenever we need it at each runner. So if I go back to the, here. So this is what is happening here. The runner deployed, I'm going to use here. Yeah, the runner deploys multiple cases and then it would just request the geospatial data, different cases, different geospatial data for each cases in parallel, and then Neptune would track them at runtime.
And you're using like CML runner to launch all those?
Yes, we're using CML to launch all of those. Yeah.
I'm curious, which part of that CML tool you feel like you got the most use out of?
Actually, the report generation. We were using it the most because the report pack, at the end of the run, we usually have to go back, before we use CML, we have to go back to Neptune and then look at each of them individually. And now we can just go on the PR and then just check everything in one go.
It's really funny that you mentioned this, because in terms of the complexity, it's a lot of effort for us to implement the runners and the automatically launch AWS instances, and comparatively not that complex to do the report functionality, and yet that's what's used the most. So yeah, I mean, we're very interested in making things that might seem simple even simpler, and obviously you're saying you're getting the most value out of that. So yeah, if you have any other pain points that you might think CML could solve, we'd be happy to hear suggestions.
Oh yeah. Like we have some, we would definitely let you guys know. But for now, we are happy with the current pipeline.
Awesome.
Is there any other questions?
Can I ask?
Yep.
So you mentioned Neptune
Yes.
stuff, right? Could you please explain how those things are integrated? So you get a report from CML, right? And also some visuals in Neptune. How do you connect those two?
Yes, so we have our own script to connect the things together. So each one cases, we use Neptune to track all of our experiment and stuff, but the CML allow us to run a custom script to create pods, and then which then send to the GitHub PR at each PR, so we can look at that at the PR itself. So this is how we use Neptune in conjunction with CML.
So
does that make sense?
Please, in general, yes, but I'd like to understand better, like how it looks like for users. Let's say I'm running a job and it reports all the metrics to Neptune, right? and
Yeah.
then the job is done, and you generate CML report. And are you providing some links to Neptune, or you getting like images from Neptune and include the images in the report, or like how, what exactly?
Yeah, so in between that, there's a post-processing metric step here. So it calculates all the metrics as well as the plot itself. And those directly just send it to, because those are in the CML custom runner. So those will directly send it into the GitHub PR itself. Those plots are created using a separated script after the job is being finished. And then we have a custom API to send, so we give a custom stuff to send it to the Neptune, so to the GitHub PR. So there's a step in between those two things.
I see. And as a result, you have like an actual plot in the report, do you?
Sorry. Yeah. So you can see the actual plot in the report. Yeah. As well as the identifier for the Neptune link, just in case there's something missing, we can always just click on it and then see whatever information is out there.
So you're saying when you do the pull request, it sets off like this this workflow, right? And you're sending the metrics to the pull request so you can see it in there, right? How are you viewing the metrics, or what do you do with those when you're doing like the cron once a week workflow?
Because we just want to make sure the once a week workflow is the algorithm is working correctly. So usually there's nothing wrong with it. Everything just giving all of the boxes, and all the sign tests or statistical tests are just fine. And then we are happy with it and move on. But sometimes there's something wrong with it. Then we will have to look at it. So it's more like a way to alert us there's something wrong.
What's that detection look like? Can you kind of speak to that a little bit?
So what kind of detection?
Like you said, the once a week is to mostly make sure everything's working fine, right? So when it doesn't, what's that detection process look like for you guys?
For us, we have the detection process is right now it's actually quite simple. We run different statistical tests, and then there will be a true or false for each test telling different things. For example, we have a sign test to tell if the algorithm can stuck in the local minimum or not. Or basically the performance compare with the previous week, the algorithm in the previous week, if it is performing better or not. There's a simple sign test to tell that. And if not all of them are returning positive, and one of us would be manually, so there's a human in the loop element in there. One of us would go into it and then check exactly what's wrong. And then we do adjustment based on that.
So you just have like, one of your workflows is one of your GitHub Actions workflows fails, and so that's what kind of like alerts you that one of the tests went bad. Okay.
Yep. That's pretty much it.
Any other questions? All right, cool. Well, thank you, Ivan. This was a totally amazing presentation, and it definitely led to a really great conversation. It's a really great thing to see like how you're using our tools in the wild. That's such a great thing, and be able to connect with other people in the community and learn about that. So thank you so much for sharing it. It's really helpful. So,
so if you guys have any question after this, this call, feel free to drop me a message on my email. So we're just here. I will try to answer it. As quickly as possible.
Awesome.
Thank you.
Thanks so much for that. Cool. All right. Well, we were supposed to have 2 presentations today, but Macon had a family emergency, so he was unable to be here today. But he will be here next month. So anyway, send good vibes for his family, please. But however you do that. But I was going to instead in this time kind of vibe off of Ivan's presentation, because I really loved how he created the beautiful architecture, and we could all see that visualization. I'm a visual learner myself, so it really helps me to see those type of architecture pipeline diagrams and things to help me understand. And one of the things that I've been talking to a lot of you, and it seems like everybody is like, everyone knows we need reproducibility, version control, the ability to collaborate with team members, automating processes. But, you know, the feedback that we're getting is that like our tutorials don't equal your real life. So it can be difficult and challenging to conceptualize things. So I have been ruminating on all these things. And then Casper also suggested that I resurrect an internal project that has like awesome DVC projects in it, and, you know, make it for the community. So the first thing though, I do, part of this whole thinking process also was that Merritt, I want to give a shout out to him. He's our student ambassador, and he is upkeeping this Meetup resources. So we're putting in all the Meetup resources into this repo. So where there are slides, or there's a repo attached to it, or the presentation will be in here, we're going to be keeping all these things in here. So I'm trying to think of ways to like make all this content and ways to learn other things from the community, like easy for you to get to in a way that you can digest it and is quick for you. So we're trying to do those type of things. So the thing that Casper suggested was that like we be a part of this awesome, and I don't know if you've ever seen that, the link is in the chat, but this is like a whole slew of amazing, awesome projects that are on the internet in different repos that you can check out. So, but we can be a part of this. And so we're like resurrecting this one repo that we have to contain like our community's awesome projects that they're using our tools with. So you would be able to contribute this and, you know, put in different types of projects that you're working on, and so on and so forth. So this exists now, and the link is there in the chat. And then the second idea that I had in regards to all of this was to create, like I've been to other community events where they use Miro to collaborate together as a community on different projects. And so given all these visualizations that we had, I thought it would be cool to create like an MLOps architecture playground that everybody could come and kind of put like, this is how we do it. And this is something that I'm challenged with. Can somebody come, like you could put in Discord, can somebody come help with how I should, you know, figure this out and what it should look like? So, so these are just some examples like that we have had from the team. Mikhail is here and he's done these, that like how he breaks it up, you know, data management and analysis, the experimental phase, solution deployment and testing, deployment and serving and monitoring. And then according to like the data science team, more of the DevOps aspect, more of the data engineering aspect, and like how all that fits in and how to figure that out. And then, you know, plugging in whatever, you know, this is where our tools are used, but you may use other tools for other parts of your process. But doing something like this, I think, can help other people understand. And like I plugged in, you know, Ivan's thing here, because this is, you know, another way to do it and how their team at Continuum Industries uses it. And so then, you know, we would keep like, this is the use case, what the application is, maybe the type of issues that they're challenged by, so that people can, got somebody coming in. You know, you can put the issues so that people can start to see, oh, they have some of the same challenges that we do, and this is how they solved it. And so it would be a way for you guys to visually be able to put that for yourself, to look at other people's things, and to also share with maybe other people on your team, new people to the team, managers that need to understand what you're doing better, perhaps, but a way to do that. And so what I was thinking was, and this is what I need help from you guys today, is like, I would want to put, like, I need an idea of how best you would want it to be organized. Like if you were going to come to this, what would be the first thing you would be categorizing by? Would it be like the type of data you use, or that? Like, that's my number one question. And then second would be like these components, like what would you like to see in here? that you could plug in. I want to make this as easy for people to use as possible. So whatever you would want to have in this bucket that you could copy and paste and add to your thing, I would like have that all ready for you so that it's here when you need it. So that's like the general idea. So I would love feedback on this, and specifically around like, what's the best way to organize it? What would you go look for first? If you were, you know, trying to find the best architecture for what you're thinking, and then like any other components or anything else. And just feedback on the idea in general. Do you think this is something that you would use or not use? This is like an open mic type of moment.
I can comment on this.
Oh.
That's might be really useful to discuss like different aspects of architecture, but we need like more details about storage configurations, how people optimize storages, because when we talk with people with a production DVC setup, if we wish, there are a lot of questions on how to optimize data flow, how to, for example, how to share one single NFS drive among all the jobs they run, how to share one NFS folder among all data scientists, how to work on how set up CML in a subset of GPU instances, how to allocate resources only one GPU per job, but not like the entire machine. And this kind of configuration will need a lot of like details about like hardware setup, storage setup, and yeah. So in terms of components, we need like a lot of different components for storages, for architecture, for GPUs, and probably templates might help. If we provide templates, for example, this is a traditional setup for shared GPU machine for data science team. This is traditional setup with NFS drive. This is set up for clouds with optimized storage usage. So that might be like really helpful.
Cool, thank you. Anyone else?
Yeah, I sort of I'm new to this, as I said like multiple times, but I sort of understand the idea of DVC, and I really like it, but there is sort of like a step away from DVC that I am still sort of unsure about how the paradigm sort of sets us up to do deployment in different forms. So for example, if I wanted to use DVC for the sort of tracking of the training and the training data, and like, you know, designing a really nice pipeline for building a model, then how do I take that and deploy it in different forms? Like I've done it in several ways, but I want to see sort of ideas of best practices, for example, to deploy a model using fast API, or deploy a model in a different sort of directed acyclic graph system like Airflow, or like, I don't know, batch operations, streaming. I don't know. Obviously, you don't have to cover the entire technology space, but it would be really nice to see examples of what you consider good practices of how to put these things. Similar to, you know, often you don't have a single model in a repo, you have multiple ones, right? Like you have a classification system that deals with a kind of information and extracts a few different kinds of data. And so you have, I don't know, a basic model that says like, this is crap versus this is good. And then from the this is good sort of set of data, you have several models that like extract entities, I don't know, of different kinds. So how do you guys recommend sort of connecting different DAGs inside of a project or something like that? If in the same way, like how do you deploy them in different forms? Maybe all of these things exist, I'm just not aware of. And then the last thing that I was thinking is sort of tracking of metrics, both when the metrics themselves are varying, and like how do we deal with that? For example, when you're trying different ideas, and you know, some ideas have some kind of metrics and other ideas have different kinds of metrics. I don't know, like this might be really difficult. But but you know, how do you guys suggest we deal with them? And then when they don't vary, like for example, if you have a model that you train every day with a different data set, and you just want to see that, you know, the sort of like accuracy is standard, and it sort of is performing well over time, and then there's no drift or whatever. What do you guys recommend for us to keep track of, like the different versions of the model and the different metrics over time or something like that? I know that these are not necessarily provided by the sort of service at the moment, and maybe you want to do it in the future, but also like, what with the technology today can we do to use these sort of things? Does that make sense, or am I rambling too much?
No, that's great.
No, that makes a lot of sense. Sorry, I was about to post the link in the chat, but I posted the wrong link. That's the correct link. Regarding metrics, yeah, we have metrics tracking. Sorry, I was going to answer the earlier point about example repositories. Essentially, there's obviously a huge number of users of DVC and CML, and I guess you could do a quick search on GitHub. But yeah, we do agree that there's a need to have kind of a best practices list of repositories and examples and projects. So I mean, I guess the people on this call are also best placed to add things to the, you know, the awesome iterative projects repository. It's quite bare right now, but yeah, I mean, we'd love to hear contributions and ideas and how people are actually using this in the wild. We definitely have the DVC org documentation website, which has a lot of ideas, but if you're talking about concrete examples of, you know, how exactly do this workflow, yeah, there's nothing like seeing an actual repository where people are doing things. Yeah, regarding the metrics tracking, provided you're not renaming your metrics names, it's just, you know, the numbers themselves are changing, then yeah, we definitely have metrics, plots and diff and graphs and that sort of thing. If you're changing the metric names, yeah, we have had discussions around that. I think Dave probably will know more about that and the status, and the issue is, yeah, how exactly do you compare two metrics if you change the name? But yeah.
Yeah, I mean, I could chime in, but yeah, Dimitri, I'm guessing these are great questions, and they're like high level questions that we thought about. So yeah, I would give Dimitri a chance to give his thoughts on it.
We definitely need like examples, as Casper mentioned, right? There are multiple use cases, and for like different use cases, we need to have some examples, like how to kind of examples with the best practices. And today with documentation sometimes like those, but we are pretty actively working on this. Casper implemented a few use cases with CML just recently, and I hope we'll have more examples when you can just like clone repository and use it as a foundation for your next projects.
And I guess regarding, yeah, so you hit on so many different points. I'm going to try to see which ones I can remember. I mean, deployment's definitely something that yeah, we're thinking through, and definitely look for more coming there. And yeah, like you said, I think that those are definitely use cases that we see both in the streaming and batch context, using Airflow, using Fast API. Those types of things are definitely on our radar, and things that we want to provide both tooling and better documentation and stuff to help guide people there. And then when it comes to yeah, as far as like having different DAGs that you want to keep organized, that's a great question. I don't know if that's something that you really have like a use case for or something. I'd love to like hear more about it, or open something on GitHub or get on the Discord, because yeah, I don't know. We definitely support that, but yeah, I don't know if we have a clear pattern documented for like, this is the best way to do it. And yeah, like we have experiment tracking today, so you could keep all of these experiments in line. And I think as far as using it as, like you said, a daily job thing where you want to monitor performance over time, I think that's something we could probably pretty easily do today. Like you could probably have a CML job that plots like, here's the performance over the last X number of runs that you've done. I think as far as yeah, as far as sort of keeping those metrics organized between different types of models within the same repo, that's something that I don't know that yeah, I'd be interested to, again, to hear your use case there, because we probably we probably could provide more in terms of support for that. Yeah.
That's great. I'll be on Discord.
Cool.
Just hit me up and I'm happy to chat.
One thing I should probably say is kind of our ethos is to also not really enforce a particular methodology or kind of system of thinking onto the users. And that's why actually DVC and CML are quite popular, because people can use their own systems. So we're a little hesitant to try and start producing kind of tutorials saying this is how you're meant to do things, and there's no other way to do it. But yeah, sure, it is definitely nice to have examples.
I get it. I think that's the reason I chose. I made up sort of like an overview of like the systems, and I chose DVC specifically because it doesn't get on the way. But it's still useful to have an example of how it might be done, right? Because then you can start from there and like diverge. Because if you like, these are your set of assumptions, and mine don't hold up, but like half of them are good, then I can use it as an example for something that I want to do. Whereas like sort of the anxiety of a blank page is or an empty repo is is real.
So true. Yeah, that's awesome feedback. I love that. Cool. So yeah, that's what we're trying to do with these ways of contributing. So using the Miro board or using our awesome projects, like as people contribute to that, then there's more opportunity for that. So that's what we're definitely working towards. Any more like feedback on this and how we could make this better?
Not much for you. I think it's a great idea. You know, a lot of it, I mean, I will be using it a little bit to try to showcase how people can, you know, use such a pipeline, a tool. You know, like, you know, look at these various, you know, methods that people have used. Because in my role, a lot of it's still convincing people to like kind of get their act together. So
cool. Yep, I was thinking of you when I was
yes.
and your comments when our talks when I was thinking about this. So thank you for those thoughts and that feedback. And yeah, if anybody, I've put my Calendly link in there, or reach out to me on Discord if you don't have any ideas right now, but you do later, just, you know, hit me up in Discord, or if you want to talk, I'd love to learn about your team and what it's about and how we can help you. So that's always open. My door's always open. So are there any other questions? We're getting towards the end here.
No, but yeah, so one thing, yeah, I just want to ask is, yeah, that would be actually a really good idea to have different use cases that different use case of DVC, because right now we don't know what it's capable of doing. We like our team only explore like a small portion of it and it fit into what our use cases really well. And yeah, and thanks to how modular this is, we can just use part of it. But it would be cool, it would be amazing to have more example on what it's capable of doing, because you don't know what you can do with something that you just don't know how powerful it is.
Right.
Yeah. So that would be a good idea if you guys can have, yeah, something a lot more, doesn't have to be real life project, but more project that we can showcase how powerful your tools are. That would be awesome. Cool.
We'll be working on that. Yeah, I talked to someone else last week that was like, they're only using the pipeline aspect of DVC, and they haven't, they're just starting, and they've been doing that for a year, but they haven't started using some of the other parts and features that it can help them with. So yeah, it's definitely a process. Cool. Anything else? All right, well, if that's all, then thank you all for being here today. Thank you so much, Ivan. This was like a super great presentation and a really excellent starter to a lot of great conversations today. We appreciate you sharing with us so much and being an awesome member of our community. Gold star, well done. And thank you all for all of your conversation and your ideas and feedback on these ideas. My plan for this is to like kind of start working it out, and maybe by the end of the month have it, all the details ironed out, and make a blog post about it and introduce it to the community so you know how to use it and where to get it. I put all the links in chat for everything. Our next meetup is November 11th. Macon will be at that one. And maybe if people start putting things in the repo, then we can share about that too and talk about those things. So that would be cool. So anyway, if reach out to us for anything in Discord, and we are here for you. And with that, that's all. You guys have a great week, month, and we will see you at the next office hours.
Thank you.
Have
you,
a great
Ivan.
day.
Thank you so much. Have a good day.
Thank you, Jim.
Thanks, Merritt. I'm glad you could stay. Bye, Ivan. Thanks.
Thanks a lot.